All right, so we have on number 2, Cole bought 3 bags of oranges for the party. When he got home, he ate 5 oranges because he was hungry. This left him with 13 oranges. How many oranges were in each bag he bought initially? Now, we're assuming something here that they didn't explicitly say, but it was said in the first problem, right here. Each family has the same amount of people in them. What about these bags of oranges? Same amount. Each bag of orange has the same amount of oranges. So I could say he bought 3 bags of oranges. Each bag had the same number. When he got home, he ate 5 oranges, leaving him with 13 oranges. How many oranges were in each bag he bought? So, is this a good match? We've already said it. Yes. Let X be the number of oranges per bag. This is when he bought them. So he bought 3 bags, 3x, he ate 5, minus 5 equals 13 left. That's a good match. Yes. What about number 3?
It's not the equation.
It's not the equation. Number 3. I think number 3, you get the right answer, but it does not give you the equation. There's one, I think I misspelled a word. Maybe I corrected it. Let's see what number 3 is. Bob bought 13 sugar cookies, and he bought 5 more that were chocolate chip. If he wanted to divide the cookies among him and 2 friends, then how many cookies will each get? Let's see. See, Bob bought 13 sugar cookies. He bought 5 more that were chocolate chip. He wants to divide the cookies between him and 2 friends. So that's 3 people. So I'll divide by 3 equals X. Okay, so that's what I got for this equation. Or I'm looking at this other page where I have some notes as well. Any of you get a different equation on this one? Maybe 13 plus 5 equals 3x? Maybe?
It's the same thing once you start trying to solve it.
You get the correct answer.
No,
But,
I mean with the problem.
oh, with these two. Yes.
Divide 3.
Yes, that's right. Those you would. Now, somebody setting up an equation to model this, maybe they would do the first one, maybe they'd do the second one. But are you likely to set up this equation? No. So, number 3 gives the correct answer. How many cookies will each one get? Each one's going to get 6 cookies. You get the correct answer, but it does not model that equation. So, this one is not an exact match. Number 3, not an exact match. Do y'all see why again? Okay. All right, number 4. Again, these were written by a previous class, and I didn't change them. Let's read number 4. So in a coffee shop, there were several different orders placed. 5 were individually placed, and they consisted of 1 cup of coffee each. So why would this group of students say 5 initially were placed? What are they thinking when looking at the equation? That's probably from the -5. So they got to figure out, I got to do something with that -5. So 3 had multiple cups per order. There were 13 total cups of coffee made. How many cups were in the 3 multiple cup orders? Oh, is this an exact match? No. In fact, there's a lot wrong with this problem. As far as looking at this equation. Look, if the question here, how many cups were in the 3 multiple cup orders? So I would say, well, that's going to be X. Let X be the number of cups in the multiple orders. You've already solved the equation. What does X equal? 6. So X equals 6 from solving the equation. What's wrong with this?
I just figured out. The answer would be 13, yeah.
Yeah, it says in the problem there were 13 total cups made. If there were 3 orders with 6 cups each, that is 18 right there. I got too many cups of coffee right there. So if there were 3 orders with 6 cups each, that's 3 times 6 is 18, but only 13 cups were made. So, and then that doesn't even count the 5 cups, right? If you had 18 made plus 5 individual orders, that would be 23. So is this one an exact match? No, 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 no way. Again, I collected some problems from you last time, and I told you this. I'm looking for some that are good matches, some that are not good matches. And these are some that were not good matches. Again, written by a previous class. So this one is not. In fact, the problem they wrote, number 4, if I wrote an equation for this, let me read it again. If I just read this problem and I said, let me write an equation. In a coffee shop, there were several different orders placed. 5 were individually placed. They consisted of 1 cup of coffee each. 13 total cups made. Okay, 3 had multiple cups. How many cups in the multiple orders? Well, I'd probably write something like this. X is the number of cups. 3x plus the 5 individual equals 13 for the total number of cups. In fact, if you solve that, there's a little problem with solving that. What would you get if you solved 3x plus 5 equals 13? 8 over 3. So 2 and 2/3. Can they make 2 and 2/3 cups of coffee? Technically, what was that? Yes or no? Yeah. As I'm asking the question, I'm thinking they probably could. They could fill up one of the cups 2/3 of the way, right? But if they have somebody placing orders, they probably think of it in whole number of cups. But I think you're right. Technically, yes.